Well, now I'm really back. Yeah, I made that up while I was not behind my PC. That might be the reason that it doesn't work. Or, so, well, at the very least here I have default constructed elements. I guess they will still be constructed after I construct my memory region owner. I mean, they should be. This is the same as just passing nothing, right? But yeah, it's important, I guess, that I construct a memory region owner base class before I construct the elements in the array. Otherwise, it will never be detected that they are in that memory region. Now we changed something. It crashes. Pure virtual method. Oh, F me, not again. Inform owner is, oh no, really? Yeah. Okay, so I can just not do that. I cannot do this from the constructor of the base class. I have to change back a lot. Oh wait, that also won't work. I need to register this region before we construct the array. So the problem is construct my array. This that will construct the base class here, which registers the memory region that's being used. And then it constructs this array, which will, hi Brian, which will construct all my t's, which then detect that they are in this memory region and call back on memory usage. But this thing here at that moment is not initialized yet. Because I'm still constructing the base classes of this array. Then the virtual table is not initialized yet for the final object here. So at the moment I'm constructing this T, I want to do the on memory region usage callback already, which fails. How can we solve that? I think that the best way to do this then is by not using a virtual function. It's the only thing I can think of. The whole idea of using a virtual function is wrong. Why does it work in the case of a class? I guess it works because then the class is constructed before the members that are inside it. Yeah. Can I not do something here as well? Something like that. Could make this a base class. Can split the array up in two classes. One that has this base class and the virtual function implementation. And then the other one is then derived from that base class and this array. So that during the construction of the array elements, the virtual function already exists. I'm not sure, however, if then I can do what I want. I'm not sure what I want to do here. Let's try it. So I need a new base class, which I'm not sure, but I don't think I have to pass any template. It could be a non-template, right? Pass a memory region, and I get that back. I think I can deal with the base class that just knows the size of each element and the starting point of it, and I can pass that. So let's make I don't know, array. array memory region. I would like to stop here though. Array memory region, but it's more like the handler. Array memory region manager or something like that. It's not the owner. Well, then it is going to be the base class, so then it is the owner. It's totally the owner because it's going to be derived from this. So we do that. And then I'll make this array memory region owner. And then I move the I can also move this, I guess. Let's move the implementation of all the virtual functions of memory region owner to this class. So now the virtual table will be constructed before we construct the array, because this one is going to be completely initialized before we construct the array and therefore the elements. But I need to call the constructor of that new base class still. So I'm going to do substitute memory region owner with our new base class. And we are passing to it a memory region. And I think I should also pass the number of elements, maybe, just. Let's pass something else. I'm going to pass the size of t, I think. That worked. If you the size of t is always equal. If you have an array of several elements of type t, then the size of the array is always n times the size of the element. And then there's no padding between the elements. And the reason is actually quite simple. The size of an array is always an integer number times the alignment. Let's say t is struct of a long and a char. Then the size is equal to twice the size of a long, not the size of a long plus the size of a char. Because the alignment is long, therefore it must be equal to multiple times the size of the long. So we can always calculate the size of the array ourselves from the size of the element and the number of elements. I'm going to pass them as arguments. And then the number of elements is of course n here. Maybe we should reverse that. No, t is up front here as well. Okay, let's put it in this order. Passing it like that. So then I have two size types, and a character pointer. So character pointer, this is my mouse buffer, that. And it is, let's call this begin. I think memory region uses that, begin. Yes. I think I do not really want to do anything else and just remember this, or oh, of course I have to do something with it. I have to pass it to the memory region owner. But I think I also want to remember these values. Let's store them. Sorry, I have to look at the memory region owner if that remembers anything I've got. Obviously. Yeah, it doesn't store anything. Well, it passes it on to tracked object, but in the end, that's just vanishes, right? That tracking has nothing to do with it. I'll just store it. Begin. I don't know why I'm using standard size type. I think size type is C or something like that, but yeah, I'm used to that. So I type std everywhere except for size type. Oh. And then you get something that is not in std, but in... I'm not even sure. Yeah, I don't know. Element size. Let's remove the std here. I know why I had the std below. I was talking to ChatGTP. And that thing came up with using std size type. Yeah, let's remove it. I'll never use std in front of size type. Extremely almost nothing. Almost never, I mean. Well, this was copied from what I already had, right? Plus, ChatGTP would never have been able to come up with this. I think I got that from Aliva, my personal C++ guru. No, I'm just kidding. Someone I know from IRC. Okay, so we have the size type and then another size type for the number of elements. Let's just put it here. Already begin. We initialize that with that, and we initialize that with that. Then we do the following thing. You start thinking again. Well, it's all nice and dandy, but I need to pass a memory region here. The memory region then is something that begins with begin, and we pass I guess it's an initialize on this thing. I'm going to pass number of elements times the element size here. Okay, now it should work. Now we should not call a pure verbal function anymore, but we should call this function by the time we are creating the elements of this array. Undefined error, use of undeclared identifier T. Oops, I just moved this here, but that was just printing the whole array. Oh, whoa. Now I have to keep that in case I want to print the whole array. But it might also be called from the memory region owner at the moment that the derived class array is not fully initialized yet. In that case, I don't want to print the elements, of course, but we can print, let's say, something that tells us that that's what it is. Like, this is an array memory owner. Wait a minute. If this is called at that point, and I doubt that this is defined, this might not going to happen. I don't know. When would this happen? It would happen, I think, from... I don't think it happens at all. At most it's gonna happen when I do it from this function. I would print anything from this function. I don't think, I want to see if it happens before I use this. So just move that back. Okay, now we have to test it. Run in the debugger, because you do crash. Ah, now it crashed at the expected point. And my assert false. So yay. So this happened at the moment that we were constructing the first element of our array. I don't know how big an A is, but it should be 1A. Memory region, just go up. Memory region. Nah, it's the size of a memory region owner. Crazy size. Doesn't have any meaning. Might as well use 1. Okay, go up. Construction of item, construction of item template, construction of node, construction of label node, construction of rectangle node, so construction of A, which comes from equal to utils array. So yes, while constructing elements inside this array, it detects that we are in that memory region, and therefore we call back the virtual function of the array memory region owner. And then I have to figure out, and this is while constructing C, I think. No, wait a minute, not yet. This is while constructing this thing here in main. That's the only one that uses that yet. Yeah, now we have to do something with it. That ain't easy. I'm wondering what happens if I do nothing. I think I have to add it to some subgraph or something. If I do nothing, then it should be vanished from my graph. So that would be a good test, I guess. What file was I editing? This one. Let's try doing nothing. Unfortunately, it's still there. How is that possible? At the moment I create this array, each element separately is still detected and added to the root graph. That's why they are here. I think that these are the ones, right? AS0, AS1 and AS2. Yeah, I guess it makes sense, because if we cannot find a memory region, although I think it was it's already added to the root graph before we even get to that point, because you begin with a normal default construction, so a default copy construction. It's constructing a temporary and then it's moving it into the array. So at the moment that we construct the first let's say the first element and then the first A of that, it's just a temporary which is then added to the root graph. On the other hand, why is it then not removed from the root graph, we would say? Maybe it's moved. It's hard, not really anything to move, but say would be able to see that, right? Let's strip off all the other code because it's getting confusing. Source, nope. So I want to have my G and I want to have, I don't even want to have this. We just want to have that and the rest is no longer interesting. The B scope open. Oh, native. Yeah, I do want to do that still. So what happens here is this A here is constructed on the stack. Well, the whole bloody array is on the stack, but it's constructed as a temporary, and then it's either copied or moved to the actual place in the array. So I should see exactly that happens. As long as we print everything, that happens. We are not. Okay, that's not helpful. Let's print what happens. So this is equal to a m a good graph. I guess this is already printed except for the m by debug output of a rectangle node. But yeah, just print everything. What followed by close. I'm too lazy to make the exception for the what. So assume that we have the what because we have it at the moment. And this one does not have a good graph. Just m and what. And this is a good construct of other. A I cannot even print an A. Cannot print A's. Let's just say this is the copy constructor-ish. I mean, it's not really when the what is there, but you get what I mean. And then I just print this pointer of the other, and then again followed by the what. No, that's still possible. Normally you cannot access other anymore after you moved it. At least that's not it's you normally, right? I mean, it's totally fine, but it's also possible that it doesn't work. So But you can still take the pointer to it. It's still at the same place in memory. And even these are being used here. Default copy constructor without the what. And now I forgot to add all the this pointers, but I think that's kind of important as well. So let's do that. So between square brackets at the end, I want this pointer. And then I add that here as well. So there would be everything up till that point. And then of course, while we print all this stuff, we also want to print the destruction, right? So the destructor. Yep, the destructor was called. So they're still there in the root graph. Everything else is gone. Let's see what happens. That's a lot. Constructing G0. It's not printing when it is done with that. And this is already constructing AS. Okay, constructing the root graph calls inform owner of 0. Really? Yeah, theoretically it shouldn't do that, but on the other hand it also shouldn't find anything at address 0, which is what is happening. Yeah, whatever. Now we start constructing the array of A's, and that does immediately like inform owner of. What the hell? Kanishk. Well, interesting, but yeah, almost impossible to get off the ground. Plus, there are already communities like that, I think. They're just not, too easy to find, maybe. Assuming the like-mindedness is here, interest in C++. And then I look at what I recently joined after I rage quit from IRC, the IC channel. Someone kicked me off the channel for whatever. So I left. And then I went to a Discord. So that's like a huge Discord server, exclusively about, well, not exclusively, but about C++ mainly, for half of it or something like that. And the rest is about lots of other languages. And there are maybe, I don't know, it's still hard to talk about interesting topics. It's still a closely knit group of people that do their thing, and then you come there as a new guy and you want to chat about how to generate prime numbers. Hey, nobody's interested. If you want to write a new application for communication, that's not going to work at all. At all. No. I have 3 monitors, and one monitor I use for chat, things like Telegram and Discord and IRC. And then the monitor is full. And I have installed Matrix, tried it for a while, and maybe another one, but then all those windows are over on top of each other. OBS is also on that monitor, by the way, so I don't see any chat while I'm streaming. Very handy. Yeah, and then someone would come along and say, hey, I wrote my own communication program. Then I would not have room on my monitor to do that. Unless it would be a close friend in real life already, or some from somewhere else. So the other things like Matrix and what all it was called, those were already good friends that I knew from Second Life. So then I wanted to try it out, but most people will stick to what they know, I think. If they use WhatsApp, they use WhatsApp, or they use Discord, they use Discord. I think, yeah, you are only going to succeed if you already have a group of close friends who are all interested in creating an app that they will use then. But if you create an app on your own, then nobody's going to join. I mean, that's like 10 years work to get it off the ground. I don't know how a Discord did that. Probably with a few $1 million. To put it on the internet in a really big way and advertise it and immediately have support for everything, and it's a extremely expensive business, I think, too. But then, okay, if you're just interested in a small group of friends, then you don't have to do that. But those friends still have to want to join. I created a Discord server for the people that join my stream, and there's a few people that come always. And nothing is happening on my Discord. And I think it's understandable, because while I'm streaming, I don't even look at it. And when I'm not streaming, then it is still people from different parts of the world that then have other things to do. So nobody is online at the same moment. Nobody's talking in the beginning. So nobody's talking because nobody's talking, and then that's how it works. Why would you even use it when nobody seems to be using it? Maybe everyone is watching it, but nobody's talking. So yeah. Let me think. On the top of my head, you need how many users did we have there? 1,000, I think. I think around 1,000 users in a single channel. I was once part of a community with 1,000 people, and then that was really nice. Then you just knew that people would be online. You just can log in and go there and chat with people, and then it starts running. But if you come online and then people wait maybe 1 minute on average, at the most, if there's nobody, and then they leave. And if you watch it and you see someone join, leave, and then 1 minute later the next one comes and looks around and leaves, and they all miss each other. It's unbelievable. Now let me concentrate on this program again. Why is this not working, man? Maybe it is working, but I don't understand what's going on here. Inform owner of what? We didn't even register our memory region yet? Or am I just not printing that? I am printing it here. Yeah. Would be nice to know what this is then. Highlight this. Now clearly that is already the construction of the first element of AS. Even before we do the register new memory region. Which then also gets added to the root graph, like immediately. It's added to G0. It's already added to the root graph before the constructor of A is even the first constructor of A is even printed. Well, well, well. Then I guess this is the second element. So this was the first element. And then here we get again the same thing, but with a different pointer. That's AS1. So, yeah, so this is second element. And then here the third element. And then finally we register the new memory region. Well, that should definitely happen before we construct anything in that region. So if these are temporaries, okay, so be it. The actual memory region apparently runs from C910 to, that looks like this is outside that region. Yeah, it is copied. So this first element here, this is a temporary that is being constructed, and here we are using the normal copy constructor to move it into the memory region, because I think that is inside that memory region. This is 7FFC3814C948. Yeah, that's inside that region. Not only that, we already detected it here. So the detection begins this constructor here has a base constructors that already do that stuff. So this thing here where this moved to begins already with the inform owner of, before it is even constructed. That might not be what I want. That should work, I think. Or not. Brian, I do that because my memory is degrading so bad that when it is full, so let's say my temporary memory is full, then I have to, I cannot take yet another path. I mean, I'm working on something. It's complex. I find that while I'm working on it, I need to fix something else. If I do that first, then I will forget again what I was working on. And if I don't add a comment, then I will forget that I have to change it. So while working on A, I find that I have to work on B, but I cannot do that because I'm working on A. It's just a memory problem. If I had a perfect memory, I could just do B and then go back to A, which is definitely what I did in the past without a problem. Or just remember it. Don't write fix me. Just do A, and then when you finish with A, you remember that, oh yeah, right, I still have to do that. But because I forget it, I started to use fix me's. I even wrote an alias that prints all the fix me's in the code. The worse your memory gets, the more tricks you start to use. Whoop. Okay, so in the end it just uses this memory region here. And that is doing nothing. I should have added debug output. Guess you can still do that. Oh, this pointer changed. Unbelievable. Oh, this is the extra debug output. On memory region usage. So this is the first element of the array. This region starts there. And that is already being called before it is constructed. Kind of annoying. So even after that call, we see the constructor of node, which is a base class of A, and then eventually we see that it was copy constructor. That copies the temporary to this new memory location. Yeah. Was this already done? I think so. So all the temporaries were added to the root graph. And we make a copy. So now the array, the element inside the array is added to the root graph. Where was that? Yeah. And the temporaries are being destructed. Oh, this was a temporary, right? Was being copied, and now it's destructed. Which then calls it to be removed from G0. The temporary is removed from the root graph. Okay, so the temporary wasn't a problem, or problem, but it's kind of the question is why is it added to G0 here? This is inside the array, right? This thing. So we call inform owner of, and then it says it calls on memory region usage. And then it adds it to the root graph. Still slightly weird though. If I find the memory region, I do, then I should not add it to the root graph. Copy constructor. Yep, I would like to have a breakpoint at this point here, but I guess that is the fourth instance that is being called after printing this. Mm-hmm. That's the first one. Second, third, fourth. Yep, after printing this. And that is being called. The array is constructed, utils array constructed. Again, then we construct an A, which is copied. And the copy constructor has a rectangle node constructor, label node constructor, node constructor. That's just a base class, and that's calling add node. Here. Okay, so this is using the root graph because the get parent graph was set or is set to the root graph. Get parent graph. I think that happened here, right? So it seems that if I set the parent graph tracker in my virtual function that currently doesn't do anything, then this is going to be unequal 0 and it's going to leave the parent graph tracker alone. So the only thing I have to do is set it. Yep, exactly. See, this is pure memory thing. I just wrote this like yesterday or 2 days ago, and now it looks like new to me. I vaguely remember this now. This calls it, and it even literally says it in the comment. Inform owner of. This sets the parent graph tracker if the object is found in a registered memory region. But we are doing nothing. Therefore, it concludes that it wasn't found. And now I got myself confused thinking, but I did find it. I just didn't do anything. But by not doing anything, I signal that it wasn't found because I didn't set the parent graph tracker. And therefore, it has set it to the root graph. So what we should do is set parent graph tracker. Oh yeah, and I remember also that that was not trivial at all. The way we have to do that is by calling set parent graph tracker with some graph. And that's not easy. I forgot how. I think I implemented that now once. I totally forgot how that worked. Maybe we can find that back. That's a lot of stuff. Let's begin at the top. Add node. Nah, it's not it. Is it? Nah, I don't think so. Remove node. add graph, whatever. Remove graph. I think this is the one. Yeah, that's the other on-memory region usage. What that does is it finds the item and then it calls on item set parent graph trigger. With some subgraph. In this case, the current object. That is a subgraph. I don't have that yet, so I can just make a static subgraph and then add that, but I still need the item. And the item is, in this case, I think pretty much the same thing as here as this. It's just it always is an item. What? You gotta be kidding me. If it is always an item, why am I not passing an item pointer then? Instead of a character pointer. Excuse me. I'm not even passing an item pointer. I'm pretty sure I just cast my A. Yeah, I cast the T. The type T of the array to a character pointer with a reinterpret cast. So it's not an item pointer. How can I find that back? What it exactly is? vi array.h. No, do that again. Yeah, this is what it is. I have this pointer here. That's the whole array. Wait. Right, no, this is the memory region that we get here is the memory region that we were calling the inform owner of on, which is an item. There might be a base class of an element. So it could be that the beginning of the memory region here is not equal to the beginning of a T. That's possible. So we have to determine where it falls inside of that. But if you look at where the on memory region is being called, on memory, Wordle must be this one. So yeah, it's the memory region that is passed to inform owner. Which is only called here. Which is the memory region that was passed to inform owner of. Let's see. Comment. This could be one. There's another one. Why do they have so many inform owner of calls? Let's start at the bottom. So this memory region is just another call to inform owner of. The output is not a call, same thing. It's just passing it on, which comes from probably something like that. Also, oh no, this is an object. Okay, so it is whatever is passed to inform owner of by a void pointer. Then we come from here. Which is passed to item. Here object is an item pointer. Just the same thing. So it's always an item pointer. I think I want to get rid of all those reinterpret casts and turn the thing into a real item pointer. So this takes an item pointer. That's a big change though. Let me get diff. Well, I might as well keep all this debug output. Yeah, okay. So it's separate files, so let's just make the change. So inform owner of object. That's here. This can be an item. And I still reinterpret cast it to a character pointer, but I want to know the item is known here. The class is known. Well, probably is forward declared. I don't even need it otherwise. Item. Nope, let's add it in here. So for declared thing. I don't really need a memory region at all, if things work anyway. In most cases I don't know the size, so I just pick something. Might as well use one, might as well not pass anything and use one. Or the size of an item. And I guess that would be a different edit. Okay, so now my object has become an item, and I might as well pass that then to. Why do I have the feeling that I might have two of them? Do I have another void pointer here? I don't. Also not here. No, I don't. Guess that's okay then. So let's not reinterpret cast this to size of memory region owner is also ridiculous, of course. Absolutely ridiculous. That isn't even derived from an item. Let's just use item here. Like I said, size isn't really important. So now we must be able to create memory regions from item pointers instead of character const pointers. Well, nah, it's not true. It's just not true. Sometimes it is something else, like if I register the array memory region, then it's something that starts at T, and then item is just the base class of that. Or this is not an item pointer in that case. So sometimes it is and sometimes it isn't. That's a problem here. Maybe I shouldn't have done this. I think I'm gonna revert it. Yeah, not good. Well, I can still make this an item, now I think about it. This is an item. That's... Wait. That is an item. But I have to pass it to a character pointer here, I think. Interpret costs char pointer. So when inform owner is being called, then even though we casted it to a character pointer, it still is an item in all cases. Although then you wonder, why would I even have this, right? If it should always be an item pointer, then why am I able to pass a memory region? This is not good, because this would allow me to call it directly with something that is not an item. Just any memory region. And in the end, it's going to cast it back to an item. That's what I do. So this function should not exist. How many inform owners do I have anyway? Another one here. Default owner. Well, it seems that my item thing is calling inform owner of, which is this one, which then calls this function, which calls itself recursively. I think I cannot pass a memory region here. That would be silly. So I'm going to change this into an item pointer. And then these two are the same, of course. So now I call this directly, which means that really I wanted to do this, at least. That's what we can do internally here. And then I also have my memory region, right? Which I then cannot pass through that one. So this can be removed. And then I have no longer that one. And also this must be an item pointer. No longer passing memory regions. Or now I think about it, why not? Because otherwise I keep creating that thing. Item memory region and just make it private. Guys, so now inform owner is being called with an item memory region, which I'm 100% sure of because this is private and only called from this, where item memory region was constructed by casting item to a character pointer. So definitely an item pointer now. In all cases. I can even rename this now to item memory region. Inform owner. Excusez-moi, where is it? Not here. Memory region 2 owner. Still a public function, but well, it's only called from, etc. I don't know. So now on memory region usage takes an item memory region. Oh, we have our item. And then I have to call on that item. But I should have copied it. Just fix me. Still not done here. Control T. So jump to it again. Next. Oh, this just set parent graph tracker. But yeah, then I need my subgraph, some new subgraph. Weak pointer, graph tracker. Yeah. I need a subgraph per index type, actually. It so sucks that I cannot play music. I'm listening to this. I think I can do that for a few seconds. Yeah, hopefully I won't get a copyright strike now. Okay, so we pass the index type to the array memory region owner. And then I need to create a subgraph per index type. Yeah, me too, Brian. I just would like it a lot more if I could play music. Kind of doesn't make sense-ish, I guess, because people could just play their own music. But I like it when when I can listen to the same music. So when I was a lot in Second Life, I would really like it to be, you're with friends, you sit around a campfire, and we play music. I really want to listen to the same music. Then you're much more together, as it were. So then, if I found out that people would not listen to the sound of Second Life, but they would play their own music, even during parties. So you have a party of 10, 20 people, and then a DJ who is live playing music, and then at least half of the people are listening to their own music at the same time, instead of the DJ. Nah, I don't like that. I think if you get together, even in a virtual environment, you have to listen to the same music. And YouTube makes it impossible. I really hate them for that. Really. So how can I create a new subgraph? Making one per index isn't a problem, but how can I make one at all? So can I just add a graph here? So that would be static, so that we get one per index. Graph. That can't work, can it? Okay, this is pure bullshit. Or is it? We probably should pass a root graph through this thing though. Which is impossible, of course. It's impossible. Well, I made a monster again. The graph is also a memory region owner. Yeah, no, please, no, no. Yeah, well, it kind of makes sense. Totally makes sense. Yeah, okay, that sucks, really. Yeah, so we don't have a graph. I want to have a. This is the graph. But then we can't have an. And then it's per object. Oh boy. Per instance. I want to have a graph per this. How are we going to do that? Why cannot we cannot do that, right? No. You got to be kidding me. Shit. I feel so stupid because it's getting over my head. Why? How? I wrote it myself. Why can I suddenly not understand this anymore? Plus, I'm writing this in order because I had the exact same problem with my Vulkan engine. In order to get more insight in my Vulkan engine. So it's just a side project in order to get more overview of my Vulkan engine, and then I get the same problem. Now I need I need this library to understand this library. I might as well give up. Yeah, I think I'm gonna stop the stream. I'm going for a walk outside. Maybe I'll get new ideas in how to add a graph here. Consider me offline. I'm just going to code a bit for myself before I leave. Is that? I think pretty much works. Just have not added the subgraph to the root graph, so that's why it's not visible. Okay, I'll be back later.